right, so this lesson is section 1, topic 8. It's the first part of parallel and perpendicular lines. But before we start, we're going to go to the left here. We're going to do a quick little review on partitioning lines. So every time we do it again, it gets better in our minds. So here we go. Consider the directed line segment, directed meaning it is moving from A to Z. So let's go ahead and put these points on our graph here. So A is at -3, 1, so it's going to be right here. And you can see that marker is not working real well. All right, A is at -3, 1, and Z is at 3, 4. And we're going to use a straight edge to connect our 2 points, A and B. This is not the straight edge I want, but I'm going to use it. Okay. This looks a little bent. Okay. Here we go. So points L, M, and N are on segment AZ. So let's go ahead and put L is at -1, 2. M is at 0, 2.5. So right there. And N is at 1, 3. Right here. Okay. Complete the statements down below. The point blank partitions segment AZ into a 1-to-1 ratio. What does that mean, a 1-to-1 ratio? It means that you have 1 on one side of the point and 1 section on the other side of the point. Equal sides, 1-to-1. So this is telling us that we're breaking it up into how many pieces? 1 on the left, 1 on the right, 2 total pieces. So which point here breaks AZ up into 2 equal pieces, 1 on the left and 1 on the right? Okay, so let's look. If we chose L, we'd have 1 section on the left, but look how big this section is on the right. That's not equal sections. But M, that one's right smack dab in the middle, 1 section to the left, 1 section to the right. So when we are breaking up into a 1-to-1 ratio, what are we really finding? We're really finding the midpoint, the point that is smack dab in between the 2 endpoints. So this would be point M. All right, let's keep going. Which point partitions segment AZ into a 1-to-2 ratio? Okay, what's that mean? It means that we're going to be putting 1 section to the left of the point and 2 equal sections to the right of the point. A 1-to-2 ratio means how many total pieces are we cutting that up into? 3. 3 total pieces with 1 on the left and a double section on the right. Okay, so let's look again. So if we use point L, we'd have this piece on the left and this on the right. Okay, so look at that. 1, that looks double, doesn't it? So I'm going to go ahead and draw the total length over and up. So if we look at this piece of our triangle right here, we have moved this direction from -3 to +3 is 6 spaces. And then up, we're moving 1, 2, 3 spaces, right? So to partition in a 1-to-2 ratio, let's first look at L. Let's look what's going on here. To get from A to L, how far do we have to move? We move to the right 2 and up 1. And if we do it again, we move to the right 2 and up 1, we hit N, and to the right 2 and up 1 again, we hit Z. So we've broken, by going right 2 up 1, we've broken this up into 3 equal pieces, with this one right here having 1 section to the left and 2 of those sections to the right, or a 1-to-2 ratio. So this would be point L. Now it looks, stands to reason that the last one here would have to be point N. So let's see. The point N, does it partition segment AZ into a 2-to-1 ratio? Okay, so using our little picture that we did here, let's picture 2 sections to the left and 1 section to the right of that, of whatever point. We are thinking that maybe that's point N right now. So let's see if point N has 2 sections to the left and 1 to the right. 2 to 1, sure does. So that's N. All right, the ratio AL to AZ. Well, how much of our line is AL as opposed to the whole thing AZ? Well, AL breaks this up into 1 out of 3 equal pieces, right? This is 1 section here, and this is total, how many of those size sections? 1, 2, 3, 3. So A to L would be 1, and A to Z would be 3 of that size. The part to the whole thing. This is a part to whole ratio. A lot of times we have part to part ratios like we did up here, 1 to 2 and 2 to 1. This is a part to whole ratio, and we decided it was a 1 to 3 ratio. Okay, the more times we see partitioning a line, the easier that is going to become. So let's move into the lesson now. Parallel and perpendicular lines. All right, so look at these 2 lines right here. These lines are, well, they appear to be parallel. Do we know for a fact they are? Yes, see those little symbols right there? Those are our parallel symbols. They look like little arrows going in the same direction. So yes, these lines are parallel. The symbol used to indicate parallel lines, we learned earlier, is that. It looks like parallel lines. These lines are, well, look, right here, there's a little square. That's our perpendicular symbol that says that these are hitting each other at 90-degree angles. These lines are perpendicular. The symbol used to indicate perpendicular lines looks like perpendicular lines, like an upside down T shape. Choose 2 points on each graph and use the slope formula, y2 minus y1 over x2 minus x1 to verify your answers. Now you may recognize this from algebra. The y direction is the up-down direction, the horizontal direction. And when you take the difference between your y coordinates, you see how far up or down that you've moved on your line. And we call this the rise. Even if you're going down, that's a negative rise, it means you're going down. x2 minus x1 means you're moving in the x direction, and this is how far you run. So that's the formula for finding the slope of a line, but we're not actually going to use this in our pictures because we have pictures. Pictures make everything easier, right? We're going to count rise over run. We're going to do what they said. Choose 2 points on each graph and count rise over run. All right, now I'm going to zoom in a little bit on this one because you really need to see where those good points are that you're picking. And you really want good points. Like, look here. That is a good point on this line because see how the grid marks are crossing each other. So that's a good point. Is that a good point? No, because it's in between grids. So we're going to go down to this. That's a good point right there. Keep going. That's a good point. All right. You have to be able to pick good points to be able to count correctly. You don't want to pick something that's like crossing in the middle of your grid markings. All right. So let's count rise and run here. I always start on the left and move to the right. We know that this line is going downhill. And if, you know, as you move from left to right, if your little car is going downhill, then you have a negative sloping line. So we know for a fact this is going to be a negative sloping line. Start here and count. Down 2, so that's -2. To the right in the positive direction, 1. So our slope for this line right here, for the first one, which is line 1, the slope is rise -2 over run 1. That's a -2 slope. I was off the camera there for that one. I'm sorry about that, guys. So line 1 has a rise of -2 and a run of 1, which is a -2 slope. All right, let's zoom back in here. Line 2, we're looking again for some good points. There's a good point. There's a good point. There's a good point. All right, let's do our rise and run. This also is going downhill. Drop 2. run in the positive direction 1. All right, so line 2 looks like it's exactly the same. Line 2 has a slope of drop 2, run 1, so a -2 slope. So what do you notice about the slopes of the parallel lines? Well, the slopes are the same. Parallel lines have the same slopes. All right, so what do you notice about the slopes of the perpendicular lines? So let's go back up to this picture, zoom in. Now these aren't going to have the same slopes because they're obviously going in different directions. In fact, this is a positive sloping line because your little car is going uphill. And this is a negative sloping line. Your little car is going downhill. So obviously we have a positive slope and a negative slope, right? Let's find some good points on it. There's a good one. There's a good one. We only need 2 good points. Going uphill, let's look at this. There's a good one. There's a good one. You only need 2 good points. All right, let's count. Downhill, remember, start with your left one. That's usually the easiest one to do. Drop 1, run positive 2. So this one has a drop 1, run 2 slope, -1/2. Let's look at this guy. This one is going, start on your left one, up to the right one. This has a rise of 2 and a run of 1. All right, let's go down and record these. Okay. In this one, let's see, line 3, this one right here, has a slope of 2/1, or 2. And line 4 has a slope of -1/2. Okay, so look at these two right here and compare them. They're using the same numbers, aren't they? A 2 and a 1. This one's positive, this one's negative, and this one right here is the flip of that one right there. So it's the reciprocal. It's the flipped right over one. So the slopes of perpendicular lines are opposite. That means one's positive and one's negative. So they are the opposite reciprocals. That's the flip. Okay, so it's opposite sign flipped over. They will make perpendicular lines. What happens if the lines are given in equation form instead of on a graph? Well, anytime you have something in an equation form, that's going to be a little harder to see instead of, you know, the picture. We love pictures, right? So what happens? Well, first you need to know y equals mx plus b is the most common format of writing a line, the equation for a line. This is the linear equation in slope-intercept form. And in slope-intercept form, this is the slope, the m number. The number, the coefficient on your x, variable x term is the slope. So if the slope is, if the two equations are written this way and the slopes are the same, you know they're parallel. And if the slopes are the opposite reciprocals, you know that they're perpendicular. Anything else, they're not parallel or perpendicular. Page. My ink has soaked through my page. It has some, but we're gonna make do. All right. Indicate whether the lines are parallel, same slope, perpendicular, opposite reciprocals, or neither. Justify your answer is going to be, we're going to go ahead and show mathematically why they are what they are. Remember, y equals mx plus b. If we can get our equations into this format where y is all by itself on one side of your equation, then the m, the coefficient on our x term, tells us the slope. So that's what we're going to aim for with every single one of these. All right, y equals 2x. Is this in y equals mx plus b format? Yeah, it is. It's just that your b is 0. There isn't one there. But we can see it right there. This is our slope for that equation. That's good. Is this one, the next one, in y equals mx plus b format? No, it's not. We have to solve for y, get the y by itself. I usually tell people to tape the y to the page and then get rid of everything around it, get it all by itself. All right, so that's what we're going to do. How do we get y by itself? You got to subtract 5 first, move it to the other side. Now look, these aren't like terms, so you're not going to be able to combine them. So you're just going to write 6x minus 5 equals, what's left over here? 3y. Okay, one more step to get y by itself. We're going to divide by 3. If you're going to divide one thing in an equation, you have to divide all of them. It's a distributive type property. So if you divide one thing, you divide all things. So I'm going to show that I'm dividing everything by 3, all the terms. There you go. This is going to give me y equals, and 6 divided by 3 is 2. And this is just negative 5/3. I'm not going to mess with that one. There you go. All right. We can rewrite that if you want. Right, y equals 2x minus 5/3. If it makes you happier to have the y on the left-hand side of your equation, doesn't really matter. The coefficient on the x term is 2, and what do you notice? The slopes are the same, so these are parallel. So if you notice, the key to this is you need to solve for y. Every one of these you're going to need to solve for y and get it into this format so that you can scrutinize what that slope is. All right, so let's look at B. Let's see if we can pick up our pace just a little bit. All right, so solving for y, here we go. Get rid of the 2x, move it to the other side. Those are not like terms, but I do want to put my x term first because that's how it's listed in my slope-intercept form, right? The x term is first. Okay, divide through by negative 5. Divide everything through by negative 5, everything. There you go. And you get y equals, a negative divided by a negative is a positive, so 2/5 x. A positive divided by a negative is a negative, 2. All right, what is the slope here? It is 2/5. All right, second one. To get y by itself, we're going to get rid of this term right here, move it to the other side. And you get 4y equals negative 10x plus 20. Divide through by 4. If you divide one thing, you divide all things. Y equals, oh, can I simplify that? 10/4. First of all, it's going to be negative, but divide them both by 2 and you get 5/2. And 20 divided by 4 is 5. There you go. All right, look at your slope. All right, so if you notice, I've got one positive, one negative, so they are opposites, and this is 2/5 and this is the flip, 5/2. So if it's opposite and reciprocal, these are perpendicular. That is a long word. All right, keep going. Okay, so get y by itself. We're going to subtract the 4x, move it to the other side. 3y equals, list your x term first. Divide everything through by 3. And you get y equals negative 4/3 x plus 21. All right, and the second one here, subtract the 12x, move it to the other side. Negative 9y equals negative 12x plus 27. Divide everything through by negative 9, everything. And you get y equals positive, 12/9. Let's see. Let's divide them both by 3, and you get 4/3 x minus 3. All right, let's look at our slopes. Negative 4/3, positive 4/3. All right, so we have opposites. We have opposites, but do we have the flip? It has to be opposite and flipped for it to be perpendicular. So just opposites, neither. All right, this is our justification here. We've justified it by showing the math. All right, next thing, x equals 4 and y equals negative 2. X equals 4 is not in slope-intercept form, is it? Because it's solved for x, not for y. But do you see a y in there? There isn't even a y to solve for on this. And this one right here, this one is in slope-intercept form, but it doesn't have an x term, which means that x is the coefficient on x is actually 0. There are 0 x's. Let's talk about these just for a second. In algebra, hopefully you learned this pretty well, and if not, this is your quick review. X equals 4 means where x is 4, that's where our line is going to be crossing. In other words, every single point on our line has an x coordinate of 4, 4, 0, 4, 1, 4, 2, 4, 3, etc. This is a vertical line. Anytime you have x equals a number, that's a vertical line. Y equals -2 means that every y coordinate for this one would be -2. So you could have anything for x. 0, -2, 1, -2, 2, -2, 3, -2. So what kind of a line does that form? That is a horizontal line. Anytime you see a line that's just y equals a number, that's horizontal. X equals a number, that's vertical. So if you can see right here, vertical lines and horizontal lines, you know, meet at a 90-degree angle. So these are perpendicular. Let's get this back here. Perpendicular. So that's just something you need to remember. If you have a vertical and a horizontal line, those are going to be perpendicular. Two horizontal lines, those would be parallel. All right, let's look at the last part of this. Write the letter of the appropriate equation in the column beside each item. All right, so we need to find a line parallel to this, a line perpendicular to this, parallel to this. Any of these equations that are not written in slope-intercept form, we have to change to slope-intercept form to make them work. But do you see one right here at the beginning that you would know automatically? Can you find a line perpendicular to, what is that? Oh yeah, that's a horizontal line. Up here in the answers, do we have a vertical line anywhere? Yeah, we do. It's right here. This one is vertical. So perpendicular to a horizontal line would be A. All right. This is in slope-intercept form. This is great. So our slope is 3/5, and this one's in slope-intercept form, a slope of -1/4. Those do not go together. But 1, 2, 3, 4 of these, we're going to have to change to slope-intercept form. So I'm going to come down here and do each one of those, and then we will see what we've got here. So here's 3x minus 5y equals -30, right? Go ahead and try this. Pause the video and change that to slope-intercept form before I do it, okay? All right, now you are back. We'll see. So trying to get y by itself, we're going to subtract 3x and move it to the other side. -5y equals -3x minus 30. Divide through by -5. Divide everything through by -5. If you're going to divide one thing, you're going to divide all things. Y equals negative divided by a negative is positive. There it is again. There we go. This one has a slope of 3/5. Okay. Let's go up here and write that. This one has a slope of 3/5. All right. Next one. Let's do x minus 2y equals -2. Subtract x to move it to the other side. List it first over here. Divide through by -2. Divide everything through by -2. Everything. And you get y equals, now this throws people from time to time. Remember that there's a 1 there in front of that x. That's -1 over -2. Negative divided by a negative is a positive. A 1 divided by 2 is 1/2. And over here is +1. So this one has a slope of 1/2. Here we'll mark it. This one has a slope of 1/2. All right, we're going to move down and do these two now. Let's do a little farther down. 4x plus 2y equals 12. Okay, subtract 4x. You really should pause the video and try each of these on your own. It'll make sure that you are good enough at changing to slope-intercept form. So each time we do that, think about it. You should just pause the video. And you get y equals -4 divided by 2 is -2x plus 6. All right, so this one has a slope of -2. And we're going to do 2x plus 8y equals 7. 2x plus 8y equals 7. Subtract 2x. You should have paused the video and tried this one on your own. 8y equals negative 2x plus 7. Divide everything through by 8, everything. And you get y equals negative 1/4 x plus 7/8. Okay, so this one has a slope of negative 1/4. Let's go mark that up here. This one has a slope of negative 1/4, and this one above it was a slope of negative 2. Okay, now we should be able to do some matching. All right, a line parallel to this one. So we need one that has 3/5 as its slope. Where did we see one? Oh, there it is. It's right there. C. Let's do this one. Parallel. Parallel is always so much easier because you're just finding the matching one. All right, parallel to this. So we need something else that has a slope of negative 1/4. So where did we find one that had a slope of negative 1/4? Uh-oh. Did I mess up one of these? Oh, we're going to come back to it. All right, perpendicular to this one, where our slope is negative 2, we are looking for perpendicular would be the reciprocal, so 2/1, flip it is 1/2, negative, positive. You want positive 1/2, and that would be D right here. So now that's going to help me figure out what on earth I did wrong. Oh, there it is. I have it circled. I just didn't even look at it. How silly of me. All right, so parallel to negative 1/4 is this one, negative 1/4, and that's B. There you go. All right, that's it. That's a lot with parallel and perpendicular. We have another lesson coming up. Topic 9 continues with parallel and perpendicular lines. But remember, if they have the same slope, they're parallel. If they have the opposite reciprocal slope, they are perpendicular. There you go.